In the vast timeline of life on Earth, most creatures leave behind nothing but silence. No bones, no names, no memory. But every now and then, something survives the erosion of time, a fossilized ghost buried in stone, daring us to ask, what was it? How did it live? And why did it vanish? But some ghosts leave behind more than questions. Some leave behind legends. And one of those legends is unlike anything else from the age of dinosaurs. It didn't have sharp teeth. It didn't run fast. In fact, by all modern standards, it wasn't particularly intelligent at all. Compared to others, it was slow, strange, and even absurd. Its body was a contradiction. Low to the ground, tail lifted high, a head barely larger than a pineapple, attached to a body the size of a city bus. Its back was armed with plates taller than a man's torso. Its tail, spiked, armored, and deadly, was strong enough to impale an attacker in a single blow. And yet, this was a herbivore. A calm, quiet grazer built not to conquer, but simply to survive. Scientists once considered it a biological joke, a dinosaur with a brain the size of a walnut. Some even believed it required a second brain just to function. Others dismissed it altogether. Too awkward, too dumb, too unlikely. And yet this animal walked the earth for millions of years, long before Tyrannosaurus, and long before even the first flower bloomed. It's often described as one of the least intelligent dinosaurs to ever live. But perhaps also one of the most misunderstood. Meet Stegosaurus, a prehistoric enigma. An animal so instantly recognizable, schoolchildren can draw it from memory. Yet so scientifically puzzling that paleontologists are still debating the purpose of its most iconic features. Why the massive backplates? Why the spike-covered tail? How did it move through a world full of predators? And most important of all, how did something so seemingly vulnerable become one of the most well-known dinosaurs in history? In this story, we'll step into the world of late Jurassic North America to uncover the real Stegosaurus. We'll explore the fossil sites where it was first discovered. We'll break down its anatomy, its behavior, and the twin forces of evolution and extinction that shaped its story. We'll investigate the science behind the mystery and the myth behind the monster, because sometimes survival isn't about intelligence or aggression. Sometimes it's about being just weird enough, just built differently, to make it through what others can't. This isn't the king of the dinosaurs. This isn't the fastest, the fiercest, or the smartest. And that's what makes it extraordinary. This is Stegosaurus, the so-called dumbest dinosaur, with perhaps the deadliest tail in history, and its story begins. Not with a roar, but with silence. Every fossil has a story. And every discovery, no matter how quiet, can crack open a new chapter in Earth's history. For Stegosaurus, that story began in the rugged badlands of western North America, beneath a sun that scorched the rocky ground and a wind that swept across open plains long emptied of giants. The year was 1877. The place was Canyon City, Colorado, part of a region paleontologists now call the Morrison Formation, one of the richest beds of Jurassic fossils in the world. It was here, while working in the dry, unforgiving soil, that a local fossil hunter named M.P. Felch unearthed something strange, something that didn't look like a predator or even a recognizable animal at all. There were no teeth, no claws, no skull. What he found instead were bones that looked alien, plates, spikes, jagged fragments of vertebrae that didn't match anything known at the time. Felch sent the bones to Othniel Charles Marsh, a prestigious paleontologist with Yale University. Marsh had already made a name for himself by naming dozens of new prehistoric species. But he was also locked in an intense and bitter rivalry with another paleontologist, Edward Drinker Cope. Their feud, a race to discover and name the most fossil species, would become known as the Bone Wars, one of the most chaotic periods in scientific history. When Marsh saw the armored bones from Colorado, he quickly realized he was looking at something entirely new. But what it actually was, That was less clear. He misinterpreted the large, flat plates as lying flat against the back like roof tiles. He assumed it might be a giant sea turtle or some kind of plated lizard. Based on this assumption, Marsh gave it its first scientific name, Stegosaurus, meaning roofed lizard. It wouldn't be the last mistake science made about this strange animal. Soon after, Marsh classified multiple species based on differences in the fossils, naming Stegosaurus armatus, Stegosaurus ungulatus, and eventually Stegosaurus stenops, which today is considered the most well-understood and iconic species of the group. As more fossils emerged from Utah, Wyoming, and further across the American West, the picture of Stegosaurus began to sharpen. But every new bone raised more questions than answers. One of the earliest and most debated features was the tail. At first glance, some scientists believed the long tail with its 4 sharp spikes was purely for display, perhaps even ornamental. But over time, through careful examination and comparisons with fossil injuries on predator species like Allosaurus, it became clear. This wasn't decoration. It was a weapon. And then came the plates, 17 broad upright structures running down the spine. Were they for defense? For regulating body heat? For signaling to potential mates or rivals? Despite over a century of study, scientists still haven't reached a full consensus. But one thing was clear early on. Marsh's original theory that the plates laid flat was completely wrong. As specimens with more complete bone arrangements emerged, it became undeniable that the plates stood tall and proud. Like biological sails, throughout the late 19th and early 20th centuries, fossil hunters brought dozens more Stegosaurus bones to light. Full skeletons were still rare, but partial findings began to paint a clearer picture of the dinosaur's anatomy. And with them, its notoriety spread. Slowly, Stegosaurus transformed in the public eye, from misunderstood oddball to prehistoric icon. Most major museums today house Stegosaurus specimens. From the Smithsonian in Washington, D.C., to the Natural History Museum in London, to the Denver Museum of Nature and Science, just miles from the original dig site, Stegosaurus became a central visual symbol of the dinosaur age. Its skeleton, squat, plate-armored, spike-tailed, is now instantly recognizable, a favorite of documentaries and children's books alike. But none of it came easily. This was not a discovery revealed in one moment on one hill by one man. Stegosaurus emerged piece by piece, over decades, thanks to the work of fossil hunters, scientists, artists, and entire institutions. It was built from fragments from rivalries and from corrections. What began as a misnamed fossil with a misaligned back eventually became something much bigger. The blueprint of one of paleontology's most unusual triumphs, a dinosaur that rewrote the rules about what it means to survive. Imagine seeing it for the first time, not in a museum, not in a book, but in the wild, a moving wall of bone and muscle pushing through the prehistoric undergrowth. Your eyes would need a moment to process it. Was it mechanical? Was it real? The creature swaying before you looked like a relic engineered from fear and survival. At full size, Stegosaurus was around 9 meters long, roughly 29 feet, or about as long as a transit bus. It stood nearly 14 feet tall from toe to the tip of its tallest plate and could weigh anywhere from 4.5 to 5 metric tons. That's the weight of an Asian elephant combined with the footprint of a small car. But numbers alone don't capture how alien it must have looked. Its legs were mismatched. The front legs short, bent almost like a reptilian elephant, while the rear legs were long and thick, muscular columns that drove its weight forward. This gave Stegosaurus a sloped posture, with its hips towering above its narrow, down-angled head. The gait was slow, with an estimated top speed of just 6 to 7 kilometers per hour, a steady plod rather than a run. Almost every movement was deliberate, bone-heavy, and quiet. The skull itself was surprisingly small for such a massive animal. Long and narrow, it ended in a tough, pointed beak. Behind it were small rows of dull, peg-like teeth. No slicing, no chewing, just clipping soft vegetation and swallowing. It had no need for powerful jaws or flexible tongues. Its digestive system did all the work, slowly fermenting plants in its enormous stomach chamber over hours, maybe days. And then there were the plates, towering from its back in two staggered rows were 17 massive osteoderms, giant flat bony structures rising from the spine like sails or jagged fins. The largest of these plates could measure over 2 feet high and 2.5 feet wide, shaped like grotesque diamonds, each bordered by ridges and vascular grooves. Unlike most body armor, these weren't fused to the skeleton. Instead, they were embedded in the skin, held upright by a complex network of ligaments and tissues. For decades, paleontologists debated their purpose. Were they an armor system, a cooling system, a mating display? CT scans and cross-sections showed dense blood vessel networks within the plates, suggesting that they may have acted like ancient biological radiators, absorbing heat from the sun in cool mornings and releasing it as days warmed. Other studies argue the plates may have flushed with color during moments of stress or reproduction, like a modern-day chameleon showing its aggression or pride, but the most unmistakable feature, and arguably its most lethal, was its tail, armed with 4 sharp spikes, each one up to a meter long. These spikes were robust, conical, and flared at the base, perfectly suited for puncturing skin, muscle, and even bone. This structure has been famously dubbed the Thagomizer, a tongue-in-cheek term that has since become widely accepted in scientific literature. Its tail wasn't just for show. Musculature reconstructions indicate that Stegosaurus had powerful tail-swinging capabilities, like a battering ram that could be driven with purpose and speed. Studies have shown that it could swing with enough force to potentially break bones or fatally wound a predator. In fact, an Allosaurus fossil has been found with a perfectly matched puncture wound, the spacing of the injury aligning almost exactly with the spacing between Stegosaurus's tail spikes. As for perception, Stegosaurus wasn't blind, but its senses were limited. Its eyes were positioned high and laterally on the skull, offering a wide but shallow field of vision, ideal for spotting movement from predators on either side, but less helpful for depth perception. Hearing was likely poor, with small inner ear structures suggesting only sensitivity to low-frequency vibrations. It didn't need keen senses to hunt, it just needed enough awareness to react. And yet, nothing about its most famous limitation is exaggerated. The brain of Stegosaurus was indeed tiny, roughly the size of a plum, weighing less than 100 grams, inside a creature that weighed up to 5,000 kilograms. That ratio makes it one of the smallest brain-to-body relationships of any known dinosaur. In the early 20th century, some paleontologists proposed the now-debunked theory that the Stegosaurus had a second brain in its hip, likely a misinterpretation of an enlarged neural canal in the sacral region. In reality, this was probably a nerve center for controlling the tail and hind limbs, not an extra brain. But should intelligence be our only measure of success? Stegosaurus didn't outsprint its enemies. It didn't outthink them either. But what it lacked in cognition, it made up for in form, a living fortress, bulky and bold, with anatomy designed not for domination, but for survival. In the chessboard of Jurassic life, Stegosaurus wasn't the king or the queen. It was the wall, the one piece you couldn't move through, and in a world ruled by claws, teeth, and speed, sometimes a wall was enough. To understand Stegosaurus, we need to understand the world it lived in, a world that has long since vanished beneath layers of rock and silence. During the late Jurassic period, around 155 to 150 million years ago, much of western North America was a vast, dynamic landscape, a humid, semi-tropical floodplain teeming with plant life. Volcanic activity and some of the most iconic dinosaurs in history. This region, now called the Morrison Formation, stretched from present-day Montana to New Mexico, and it was here, under the canopies of massive conifer forests, that Stegosaurus roamed. At ground level, the forest was a maze of ferns, cycads, horsetails, and ancient shrubs. The air was thick, the soil rich, and streams carved slow pathways through valleys of volcanic ash. The climate was warm, often fluctuating between seasonal dry spells and heavy rainfall. It was an ecosystem perfectly suited for colossal plant-eaters and the predators that hunted them. Among these giants, Stegosaurus carved out its routine, heavy, solitary, and deliberate. Stegosaurus was a low-to-the-ground browser. Its posture, with short forelimbs, long hindlimbs, and a neck that angled downward, was ideal for feeding on low vegetation. Its beak-like mouth could clip through stems and soft leaves, consuming large quantities of ferns, mosses, and other ground plants. Inside its jaws, the small leaf-shaped teeth were not built for grinding, only for basic shredding. Chewing never really happened. Instead, food passed into a vast gut where it was broken down slowly through fermentation, aided by microbes, much like how modern-day elephants, horses, and iguanas digest coarse plant material. A typical day for Stegosaurus likely involved long hours of foraging. It would move slowly across open patches of foliage, head low, tail high in the air like a rudder, its backplates rising visibly above the grass and underbrush like jagged sails on the horizon. Its movement was unhurried, almost mechanical, possibly covering only a few kilometers per day as it fed. It focused not on speed, but on volume, eating enough to power a 5-ton body one bite at a time, but feeding time was always shadowed by the threat of predators. The Morrison Formation was also home to some of the Jurassic's most efficient carnivores, including Allosaurus, Ceratosaurus, and possibly smaller pack hunters. And although Stegosaurus lacked armor along its flanks, it had other strategies. It likely relied on a heightened state of environmental awareness and, most importantly, its tail. Evidence from fossils, including a punctured Allosaurus vertebra, suggests that this tail wasn't just a weapon of intimidation. It was a last line of defense, capable of killing. Defensive behavior may have included turning sideways to present the full width of its plates and maintain visual contact with its attacker. The tail, held rigidly off the ground thanks to powerful rear muscles, could swing in a wide arc, potentially delivering a fatal strike. And we know Stegosaurus used it, not just possessed it. The design was too specific, too evolved to serve no purpose. It was never meant to chase. It was meant to wait and warn, and if necessary, react with violence. As for behavior among its own kind, the fossil record is limited but suggestive. Some trackways show that multiple Stegosaurus individuals walked together, possibly indicating loose group behavior, especially during migrations or seasonal movements. There's no evidence of complex herding like later dinosaurs or modern mammals, but they may have tolerated each other's presence across shared feeding grounds. Whether they competed for mates, displayed through their plates, or kept strictly solitary outside of breeding season remains unknown. Social signals may have been largely visual. With no known vocal anatomy, Stegosaurus probably didn't communicate using sound in any complex way. Instead, the raised plates, rich in blood vessels, may have changed color with temperature shifts or mood changes, acting like early biosignals in aggressive or mating displays. Stomping, tail movements, or even posture shifts might have been enough to communicate warnings or interest to others of its kind. At night, Stegosaurus would likely retreat closer to forest cover or water sources for safety. After long hours of movement and constant grazing, it would settle into rest, tail curled near its body, eyes watching from the shadows. The glow of the sun would fade across the edges of its plates, and the calls of Jurassic insects would begin to echo through the trees. This was its rhythm, not of dominance, but of routine. Stegosaurus wasn't just a dinosaur built for defense. It was a creature shaped entirely by caution, cautious movement, cautious feeding, cautious survival. Its world was dangerous, always shifting, and ruled by those who could adapt or defend. And in that world, Stegosaurus carved a place, not with speed or intelligence, but with towering patience, enduring biology, and a weaponized tail that made even the kings of the forest think twice. Every species, no matter how mighty, eventually faces a reckoning. For Stegosaurus, that moment came not with a cataclysmic blast or a sky turned to fire, but with a quieter collapse, the kind that doesn't arrive in a single afternoon, but unfolds slowly, over thousands, perhaps millions of years, until one day, there's nothing left and no one to remember. By around 150 million years ago, Stegosaurus disappears from the fossil record. And while the exact cause of its extinction remains uncertain, paleontologists believe it was part of a broader ecosystem transition, not a sudden mass extinction, but a shift in climate, landscape, and competition that gradually pushed the species out of existence. The lush, fern-filled floodplains of the Morrison Formation began to change. Volcanic activity may have altered local environments, creating drier seasons and soil disruption. The plants Stegosaurus depended on, soft cycads, ginkgos, and ground-level ferns, began to give way to harder, more fibrous plant life. New species of flora emerged, including the earliest flowering plants, along with herbivores better suited for digesting them. Meanwhile, sauropods like Apatosaurus and Camarasaurus continued to dominate vast feeding grounds, their long necks granting access to untouched canopies above. Smaller, faster herbivores evolved, more agile, more adaptable. Stegosaurus, with its slow gait, simple teeth, and limited mental processing, may have found itself increasingly unfit for the ecosystems taking shape around it, and predators were evolving too. Theropods were becoming smarter, faster, and more diverse. Pressure mounted from both ends, from hungry mouths and from disappearing food. Stegosaurus was caught in the middle. No meteor marked its end. No single extinction layer buries its bones. It simply vanishes, slowly, silently. Entire populations dwindled, one habitat at a time, until its line was finally irreversibly broken. Unlike some dinosaurs whose descendants became birds or reptiles that eked out a legacy through crocodilians, Stegosaurus left no evolutionary survivors. Not a single lineage pushed forward. Its unique body plan, the plates, the tail spikes, the sloped frame, vanished completely, as if nature had designed this creature as a one-time experiment, and quietly shelved it when the rules of the world started to shift. In the end, Stegosaurus was not undone by violence, but by time itself. Its extinction marked the close of an era. By the time the Cretaceous period solidified, its niche was gone, its world rewritten by new climates, new species, and new realities. Today, its bones lie dormant in stone, displayed in museums and buried in dry, remote rock beds. And even though millions visit its skeleton each year, few stop to consider there was no asteroid for Stegosaurus. Only wind, water, dormancy, disappearance. Its ending was unspectacular. But perhaps that's more haunting. Not all legends vanish in flames. Some just fade away. What if it never went extinct? What if, somewhere on this planet, hiding in a lost valley, a forgotten wetland, a forest untouched by machines, Stegosaurus still lived? It's a question as impossible as it is captivating. Could such a creature survive in the modern world? Could it adapt to heat waves, flashing lights, concrete barriers, and screaming highways? What would it mean to see this plated titan walking again, freely, in the world we shaped after it was gone? Let's imagine a 5-ton animal with towering plates and a 4-spiked tail, wandering through temperate forests or grazing beside rural farmlands. Powerful but slow, peaceful but imposing. News crews would descend within hours, drones in the sky, experts scrambling for insight, and the world would stop for a moment, fascinated by a ghost from the Jurassic. Some would celebrate, others would panic. Governments would lock down the area, Scientists would argue over how to classify it, what protections it deserved, what rights it had. Would it be placed in a sanctuary or a cage? Would it become a symbol of conservation or an outcast of evolution? There would be obvious challenges. Stegosaurus lived in ecosystems with no modern equivalent, dense with ferns, warm and unpolluted. With its slow metabolism, sensitive digestion, and limited cognitive ability, it wouldn't last long without specialized care. Its food would need to be cultivated, its movements protected. The modern world is not generous to giants. Its anatomy would seem alien. Tourists would gawk at the armor plates. Scientists would puzzle over its tiny brain. Children would draw it. Companies would market it. And someone, somewhere, would try to profit from it, and still it would stand there massive and quiet, unaware of the frenzy it has caused. Uninterested in politics or profits, it would continue, as it always did, to do one thing: eat and survive, slowly, carefully, on legs that once carried it under the shadows of Allosaurus. Unaware that the new predator is now human curiosity itself. If it had survived extinction, would we protect it? Or fear it, respect it, or repeat the damage all over again? There's something tragic in that thought, that even a second chance might not be enough, and yet the very idea haunts us. Because if Stegosaurus walked among us today, perhaps we'd be reminded how fragile the world is, how evolution doesn't always choose intelligence or speed. Sometimes it chooses armor, sometimes it chooses survival through stillness, and maybe, just maybe, we'd remember that losing something doesn't always come by violence. Sometimes we erase things simply by not making room for them, a world moving too fast, a creature built to move slowly. That's the disconnect, because in the end, if Stegosaurus lived today, it wouldn't be the planet that had to adapt to it. It would be us, in a world no longer made for giants. Would it still walk the earth?